Hey Panthers, it's Mrs. Sherburne. I'm in my kitchen, but today instead of doing some cooking, we're gonna do some chemistry. You know, we've started our new unit on chemical reactions, and there are 5 different types of chemical reactions. The first one is single replacement, double replacement, combustion, combination, and decomposition. I'm going to do 5 different videos, kind of focusing on a demonstration or an activity that we would have done together in the lab for each of the different types. With each of the videos, I want you to think about these 3 things. Can I balance the chemical reaction that goes with the demonstration? Can I identify what type it is? So of these 5 different types, what's being showcased in the video? And can I draw a picture or a particle model of the reaction? Okay, so let's get started. The first reaction that we're going to do today involves hydrogen peroxide and beef liver. You may remember around Halloween we did a reaction inside the puking pumpkin with hydrogen peroxide. Do you remember why it's in a brown bottle? It's in a brown bottle because it naturally decomposes if it's exposed to light, so the brown plastic keeps light from getting in. So we're going to do the same kind of reaction today, but instead of using light, we're going to use blood. So kind of a spoiler alert, you've already seen this reaction if you put hydrogen peroxide on a cut. Blood has an enzyme or a catalyst in it that makes this breakdown happen a lot faster. The enzyme or the catalyst is known as catalase. All right, so I'm going to put some hydrogen peroxide in this little bottle. I probably should have grabbed a funnel. We'll see how this goes. And a piece of beef liver. This is one of the reactions you would have done with your lab partner. Okay. I went and grabbed a funnel. That's probably good. All right, come a little closer. We also can test what type of bubbles are being produced. This is not working. Did you see it glow brighter as it fell into the bubbles? All right, let's talk about the chemistry that's happening with this reaction. Okay. So hydrogen peroxide, we already talked about it breaking down to make water and oxygen gas. We know it's oxygen gas because that flame glowed brighter as it fell into the bubbles. So here's what we call a skeleton equation. Hydrogen formula for hydrogen peroxide, which is a liquid, breaks down into water, which is also a liquid, and O2, which is a gas. We talked about oxygen being one of the 7 diatomic elements that comes in pairs. So that's why I drew 2 the 2 with the subscript there for the O. So the very first thing that I want us to focus on is balancing this equation. And we're going to kind of do that in conjunction with drawing a picture. So if you notice the arrows here, what's in front of the arrow are our reactants, and what's after the reactant, after the arrows are our products. And the goal is to have the same amount of all the particles that we have, so same amount of O's and H's in front of the reaction and after the reaction, the things that we make. So you can see right now that we do have 2 H's in what we made, and we also have 2 H's here, so those are great. The O's, I have 2 here, and combined on this side, I have 3. So I know that I'm going to have another hydrogen peroxide. So I'm going to make and draw and when you draw these molecules, you just want to make them as symmetrical as possible. Why didn't I just draw 1 more O? I needed 3 to balance it. Why didn't I just draw that? Well, that's not hydrogen peroxide. So if I want more O's on this side, I have to draw a whole nother hydrogen peroxide. So now you're saying to yourself, I still don't have the same amount of O's, and my H's aren't balanced anymore. Well, how many H's do you have on this side? You have 4. Can you make 4 on that side? You're probably saying to yourself, yeah, if I draw another water. You're absolutely right. So now I have 4 H's on both sides. And when I did that, that made it so that I had 4 O's also. So this is the picture, this is the particle model of what's happening with this reaction. The last thing you need to do is count how many molecules you have of each thing. So over here on this side, I have 2 hydrogen peroxides. So I'm going to draw a 2 in front. That's known as a coefficient, just like in math class. The big number you put in front of x, or any of the variables, is a coefficient. I drew 2 waters, so I'm going to need 2 H2Os. And over on this side, I only have 1 oxygen molecule. Just like in math class, you don't write 1x typically, you just write x. So you don't have to put a 1 here, you can just leave it like it is. Okay, so we've got 2 of our 3 goals. We've got the equation balanced, we drew a picture of it, now we just need to identify what reaction type it is. And if you remember, our 5 reaction types are single replacement, double replacement, combustion, combination, decomposition. All right, take a second and pick one based on what you saw with the reaction, which we should zoom back over to the reaction for a couple minutes. And let's try another match. If you see the match glowing brighter, that's a good indication that it is oxygen gas. Okay, last thing that we were doing, we were picking a reaction type. And if you pick decomposition, you are right. Hydrogen peroxide decomposes. I could have said decomposes instead of breaks down. That is our reaction type. All right, Panthers, stay tuned for the next video where we'll focus on one of the 4 reaction types that are left. Thanks, Panthers.